And welcome back. Today we're going to be talking about similar polygons. And the three big ideas that we're going to hit here is how to write similarity statements, how to find and use scale factors, and actually using similar polygons. So if you're ready to go, let's get started. The first thing that we want to talk about are similarity statements. These are very similar to congruent statements, except the notation is a little bit different. Two polygons are said to be similar if their corresponding angles are congruent and the corresponding sides are proportional. And we're going to talk a lot more about that here in a moment. Now, in actually writing a similarity statement, in this diagram, these two polygons are similar to each other. ABCD is similar to EFGH. Note that the order is very important. Angle A corresponds to angle E. Angle B corresponds to angle F, angle C to G, and angle D to H. They are in the same relative position. So when we write a similarity statement, we use this notation. Note how this symbol right here looks like the little squiggly that we put on top of the equal sign for congruent. So this right here is red. ABCD is similar to EFGH. With that in mind, let's talk about the corresponding pieces. So this is the same diagram from the last page. The corresponding angles, we talked about this. Angle A was corresponding to angle E. That means that angle A is congruent to angle E. On the last page we said that for stuff to be similar, their angles have to be congruent. So we say angle A is congruent to angle E. Angle B then is going to be congruent to its corresponding angle, angle F. Angle B is congruent to angle F. Angle C is going to be congruent to its corresponding part, angle G. And angle D will be congruent to its corresponding part, angle H. So those are our corresponding angles. Now when we're talking about the ratios of corresponding sides, first off, corresponding sides, that means AB corresponds to EF. They're in the same relative position. They have the endpoints that correspond to each other. Angle A corresponds to angle E, angle B to angle F, so AB corresponds to EF. And we write that as a ratio. Now, we said that the corresponding sides are proportionate. What that means is whatever the length AB divided by the length EF is, that's going to be the same as BC to FG. These all need to be equal for these to be similar. So then we also have CD over GH and AD over EH. This is showing proportionate sides. It is also very important to remember that whichever figure that you start with on top needs to stay on top for the entire proportion. AB to EF, BC to FG, CD to GH, and AD to EH. All of the top ones are in the red figure. Okay. So, for example, in this diagram, the two triangles are similar. The first thing we want is a similarity statement, and then identify the corresponding parts. So we're talking about the corresponding angles and the corresponding sides. So again, we need to make sure that we have this in the proper order. Order definitely matters. If we say TSR, then we need to say Z, Y, X. If we say SRT, then we need to say YXZ. How did I write it? I wrote it TRS is similar to ZXY. Those are the corresponding angles. So now let's enumerate them. Angle R down here, is congruent to angle X. They are corresponding angles. Angle T is congruent to angle Z because they are corresponding angles. Angle S is congruent to angle Y because they are corresponding angles. Lastly, we have the corresponding sides. I believe I started with the big triangle on top. So I took TR to ZX, RS to XY, and TS to ZY. Again, these equal signs, that's just telling us that these are all proportionate. Okay, let's move on. Alright, in this example, the only thing I want is a similarity statement. So take a moment, write out a similarity statement, and check it against mine. Now wait, these figures aren't in the same orientation, so G does not correspond to Q. We have to flip these about in our minds to get them in the same orientation so that we know which ones line up. So what I came up with is that this quadrilateral DEFG was similar to PQRS. And this is one acceptable similarity statement. You guys, I like to go alphabetical. If you started with G and you went G, F, E, D, then you would have ended up with S, R, Q, P. So it's really a matter of where you start. But just like with congruent statements, the first letter and the first letter need to be corresponding angles. The second and the second, the third and the third, the fourth and the fourth. Those need to be in the same positions. All right, let's move on to something a little bit more challenging. Scale factors. And we talked about scale factors whenever we discussed dilations. So that term should be relatively familiar. All right, so it says if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. Okay, right now that sounds like a whole bunch of warble, but give me a minute. So for example, the scale factor of DEFG to PQRS, assuming that DE is 9 and QP is 5, those are two corresponding sides. So we are going to make a ratio of their side lengths. So I put this as 9 to 5. Now again, the order that you're going to do this is going to depend on if it says what is the ratio of DEFG to PQRS or backwards. Because remember, the first one is always the one that goes on top. So we put the side length DE to the side length QP because those are corresponding sides. This is the scale factor. So let's try an example. Oh, let's not. To determine if polygons are similar, we must show that all of their sets of angles are congruent and all of their sets of sides are proportional. And that's just kind of a reminder from the beginning. So now we're ready for an example. Okay, first we want to know, are these polygons similar? If they are, then what is their scale factor? So what we just said a moment ago, for these to be similar, all of their angles have to be congruent and all of their sides have to be in proportion. So let's look. Are all of their angles congruent? Are all of their sets of angles congruent? Well, W is a right angle and so is J. Z has one swishy. F has one swishy. X has 2. H has 2. Y has 3. G has 3. So yes, all of their angles have a matching partner in the other polygon. Do we have proportional sides? This is where we have to do a little bit of math. So if these were going to be similar triangles or similar polygons, then WX would have to be in proportion to JH, ZW to FG, ZY to F, I'm sorry, did I say FG? I meant FJ. FJ to ZW, ZY to FG, HG to XY. And that's what I wrote right here. This is what has to be true in order for these to be proportional. So FJ is 16, ZW is 20. What I did, I took the numbers and I plugged them in right here. So FJ was 16, ZW was 20, FG was 20, ZY was 25, GH was 24, YZ was 30, and JH was 12, and WX was 15. Okay, well, all of this stuff doesn't really make a whole lot of sense to me because it's a whole bunch of fractions. So what I did, I took out my calculator and I reduced these to decimal form. What I got for 16 over 20 was 0.08. I'm sorry, not 0.08, 0.8. 20 over 25 was again 0.8. 24 to 30 is 0.8. Now, Miss Hart, isn't that enough? Do I have to keep going? Yes, you do, because if this last one is not 0.8, then these are not similar figures. Luckily for us, it is 0.8. Yay! So are these sides proportional? Yes. Check mark. So then, if we have both congruent angles and proportional sides, then yes, we have similar polygons. Ta-da! Now the last thing, what is the scale factor? Well, we said that the scale factor was the ratio of any corresponding sides. So we could have done FJ and ZW. We could have done GH and YX. That's this fraction. Okay, well, all of these fractions reduce down to 0.8. So that is our scale factor, the ratio of any of those sets of corresponding sides. All right. So the main idea here is if two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. Okay, again, that sounds like a whole bunch of warble, but this is exactly what we just talked about. If these are similar, then the scale factor is going to be true across every single set of sides. So that's what this is saying. Okay. Last couple of examples. These polygons are similar. I'm telling you, they are similar. So first off, we want to know what is the scale factor, and then we want to know what is the value of x. So to find the scale factor, we pick any of these corresponding sets of sides. I did 12 and 6, AB and QR. You could have picked AD and QT or DC and TS, whatever you'd like, but it has to be one where both of them have numbers on it. You could not have picked BC and RS because that one has an X. So I picked 12 to 6. So that made my scale factor 2. If you had picked 10 to 5, that would still have made your scale factor 2. 16 to 8, still make it 2. So then the second thing is, what is the value of x? So since all of these sides are in proportion, what we're going to do, we're going to take whatever we picked up here, and we are going to set up a proportion with BC and RS. So if you picked 10 and 5, then you're going to have 10 over 5 equals x over 4. I picked 12 over 6, so this is what I came up with. 12 over 6 is equal to x over 4. Remember, the top has to be both numbers from the same polygon. So do the bottom. So if you put 12 on top, you better have x on top. If you put 6 on top, you better have 4 on top. They need to come from the same polygon. So with that proportion, cross multiply, set it equal to each other, I ended up getting x equals 8. And you should have gotten that no matter which ratio you started out with. Okay, one more. These polygons are also similar. What is the scale factor, and what is the value of x? So this time there wasn't a whole lot in the way of choices. You had 15 and 15. I mean, you didn't have anything else. This 25 over here corresponds to this x over here. We have to use stuff with numbers so that we can get a numeric scale factor. So our scale factor is going to be 15 to 3, which I reduced that down to 5. To get x, we need to set up this proportion 15 over 3 and then set it equal to 25 over x. If it's not 25 over x, it is wrong. So whenever we cross multiply this out, we get 75 equals 15x, and that makes x equal to 5. All right, that's all I have. So for your homework, you will have the 10 problems. Do as much of it as you can. If you have any questions, we will go over it tomorrow. Thank you, and have a good day.